Our series of basic process engineering calculations. In last session, we have seen or we have focused on how to calculate the NPSH available for the certain conditions, like where the first is the uh, NPSH available calculation for the suction head available condition, and the second case is for the NPSH available calculation for the suction lift. Okay, so in this session we calculate the NPSH available under vacuum condition. Okay, calculations under vacuum condition. Okay, so here I have taken one example to calculate the NPSH available. Based on that, so we can just simply put it down the whatever parameters available with us. First is static head available. What is a static head available? Here in this example, we are transferring or we have connected suction line to this tank, which is under vacuum of 450 mm of Hg, and we have pressure gauge to check that vacuum, or we simply called it as a gauge. Vacuum gauge or pressure gauge, both are same, just it indicates the vacuum in negative pressure. Okay, -1 to 1 bar gauge. And this is a static head, which is the basically distance between the center line of pump to the height of liquid in a tank. Okay, and here we have already taken the calculated friction factor, so that we can avoid these repetitive calculations and focus on the main content. Here we have static head is of 8 meter, then pressure drop across the piping and fitting at suction. Okay, in one of the our session we have said or we have explained how to calculate the pressure drop across the piping using the Excel sheet with the Darcy-Weisbach equation. Okay, and you are aware that to calculate NPSH available, what are the parameters required? NP NPSH available is equals to static head plus, just revising that so that you will get more idea, P absolute above the liquid surface. Okay, minus pressure drop to due to friction at suction minus vapor pressure of liquid. Okay, so I just simply wrote that down here so that you can revise and get more clarity. So now we have static head and the uh, delta P due to friction. So now we can just simply wrote down like liquid density. Here we considered the liquid density is 800 kg per meter cube, or specific gravity is zero point 0.8 meter. Okay, so now based on that data we can uh, just check at 40 degrees Celsius. We have considered this example at 40 degrees Celsius we are transferring material. So vapor pressure of liquid at 40 degrees Celsius. So simply we wrote it down here. Vapor pressure of liquid is zero point 0.6, okay, kg per centimeter square. Okay, so now we have to calculate the P absolute. Rest of the things are available with us. P absolute. Okay. So first we will check the P absolute is what is the pressure available above the liquid surface. Here we have 450 mm of Hg vacuum. Okay. So to proceeding further, we calculate the first liquid vapor pressure. Okay. Liquid vapor pressure is equals to zero point 0.6 into 10.33 meter divided by density or specific gravity. So it is the available vapor pressure of liquid is 7.747. Okay. Now we calculate the P absolute. Okay, as the suction is under vacuum, we calculate P absolute in suction in tank. Okay, so to calculate that, we have to minus full vacuum is 760 mm of Hg minus, we can wrote it down here is, okay, so 450 mm of Hg. Okay, okay, pressure at tank liquid. Okay, so P absolute we convert that mm of Hg. Okay, that we need to convert into meter. Okay, to convert that simply need some conversions divided by specific gravity into 1000 so that we get the P absolute in meter. Okay, so now we have all the parameters which are required to calculate the NPSH available. So NPSH available is equals to static head plus P absolute minus vapor pressure and the delta P. Okay, so we got the, okay, we got the NPSH available is 3 meter. Okay, so hope you got the clarity about this. So we'll consider another example with the same, and there we are just using as a condensate transfer pump. Okay, so that I can take the example NPS available calculation under vacuum for condensate transfer pump. Okay, so we just first I'll just take example details here so that we get the idea. This is the condensate tank which is having pressure of vacuum of 688 mm Hg, and it's having static head of 4.6 meter, and delta P due to friction is already mentioned here, so we need not to calculate, which is 1.2 meter. So we will consider the same here. Okay, I just copy paste here so that it will reduce the time. So we just simply change the values, which is static head available is 4.8 meter. Then delta P across the piping is 1.2 meter. Then density of the material is 1000 as it is water condensate, and we can, as it's water condensate, that means ki vapor pressure we needs to calculate, and it's equals to P absolute. Okay, liquid vapor pressure. Here we need to calculate the vapor pressure. Okay, liquid pressure is equals to P absolute. So here we have vacuum of 688 mm of Hg. So we simply done the calculation, which is 760 minus 688 mm of Hg. That means ki 72, and that we have converted to meter. Okay, and vapor pressure is here. So we just simply calculate the NPSH available is the static head minus vapor pressure plus P absolute and minus the delta P across the pipe and fittings. So for this case, our calculated NPSH available is 3.6 meter. So we just summarize that for the calculation of NPSH under suction lift, we need to minus the static head or suction lift head, and in wherever we have positive suction head, we need to simply plus that into the NPSH available calculation. Okay, so another example we just considered for the pressure vessel. Okay, we just assume that this is okay, we just assume that the case phi. Okay, case phi is for the NPSH calculation. I simply copy paste it here. Okay, and we consider this case phi for the NPSH available calculation for the vessel which is having two bar gauge of pressure applied on the liquid surface instead of this vacuum. So static head and other parameters will keep same as it is, and we calculate the NPSH available for this. Okay, static head is 4.8 and the pressure drop across the fitting is 1.2. So we simply change is we simply calculate vapor pressure. We assume zero point 0.6 meter for the transfer liquids. Okay, and here we have available NPSH available. We can calculate. Okay, in this case, we have two bar gauge of pressure available above the liquid surface. So we have simply note it into absolute. We converted that 3 into absolute and simply put it down. P absolute is static head plus P absolute minus delta P across the fitting and the vapor pressure. So hope you got the clarity about how to calculate NPSH available for the different conditions. Still you have any doubt, you can drop me a message or you can mail or you can comment in a comment section so that I can get back to you. So thank you for now. Bye bye.